This video covers content from Chapter 3, Section 2, where we will begin graphing our linear equations along with their intercepts. First, let's define what x-intercepts and y-intercepts are. An x-intercept is a point at which a graph crosses the x-axis, while a y-intercept is a point at which a graph crosses the y-axis. One way to identify any intercepts is to look at the graph of an equation. Let's walk through each of these four graphs and identify any intercepts. Our first graph has an x-intercept right here, where the graph crosses the x-axis. That is the point -5, 0. This graph also has a y-intercept where it crosses the y-axis here, and this is the point 0, 5. Moving on to our second graph, this graph has an x-intercept where it crosses the x-axis here. That is the point 4, 0. It also has a y-intercept where it crosses the y-axis here, at the point 0, -8. Looking at our third graph, we have no x-intercepts because our graph never crosses the x-axis. However, we do still have a y-intercept here, where the horizontal line crosses the y-axis. And this is the point 0, 6. On our final graph, we do have an x-intercept where this vertical line crosses the x-axis here. And that is the point -3, 0. This graph, on the other hand, does not have a y-intercept because it never crosses the y-axis. It actually runs parallel to it. Another way that we can identify intercepts is by looking at the equation. In order to find an x-intercept, we substitute 0 for y and solve the resulting equation for x. To find a y-intercept, we substitute 0 for x and solve the resulting equation for y. Quickly look back at our previous four graphs. Notice that on each of our x-intercepts, the y value is 0. And on each of our y-intercepts, the x value is 0. That is, to find an x-intercept, set y equal to 0. To find a y-intercept, set x equal to 0. Let's practice this concept in example 1. Starting with part A, let's find the x-intercept by setting y equal to 0. If we substitute y equals 0 in our original equation, we have -3x plus 4 times 0 equals -12. 4 times 0 is 0, so this is -3x equals -12. Dividing both sides by -3 allows us to isolate the x, and we have x equals +4. This tells us that we have an x-intercept at the point 4, 0. X is 4 and y is 0. Now let's look for a y-intercept. To find a y-intercept, we need to set x equal to 0. Substituting x equals 0 into our original equation, we have -3 times 0 plus 4y equals -12, and we can solve for y. -3 times 0 is 0, so this leaves us with 4y equal to -12. Dividing both sides by 4, we have y is equal to -12 divided by +4, or -3. That means that we have a y-intercept of 0, -3. X is 0 and y is -3. Let's now look at part D, still in example 1. We will again start by looking for an x-intercept by setting y equal to 0. Substituting y equals 0 into our original equation, we have 0 equals -3x plus 15. To solve for x, we'll first move the constant term to the other side of the equation by subtracting 15 from both sides. This gives us -15 equals -3x. To further isolate the x, we'll divide both sides by -3. -15 divided by -3 is a +5. So we have x is equal to +5. This tells us that our x-intercept is the point 5, 0. X is 5 and y is 0. Now we can find our y-intercept by setting x equal to 0. Substituting x equals 0 into our original equation, we have y is equal to negative 3 times 0 plus 15. Negative 3 times 0 is 0, so we have y is equal to 15. Now we know that we have a y-intercept at the point 0, 15, where x is 0 and y is 15. Let's go on to example 2, where we will use these intercepts to help us graph these linear equations. In example 2, we are asked to graph the linear equation, and we're going to do that by labeling our intercepts. In part A, let's start by finding our x-intercept and our y-intercept. We will first find our x-intercept by setting y equal to 0. Substituting y equals 0 into the original equation, we have 2x minus 3 times 0 equals 12. 3 times 0 is 0, so we have 2x equal to 12. And dividing both sides by 2, we have x equal to positive 6. We now know that our x-intercept is the point 6, 0. And we can plot that point on our graph by going to the right 6 and stopping there. Now let's look for our y-intercept. To find our y-intercept, we will set x equal to 0. Substituting x equals 0 into the original equation, we have 2 times 0 minus 3y equals 12. 2 times 0 is 0, so we have negative 3y equals 12. Dividing both sides by negative 3, we have that y is equal to negative 4. This tells us that we have a y-intercept of 0, negative 4. We can plot the point 0, negative 4 by not going left and right, but only going down 4 units. Now that we have these two intercepts, we can graph the line that corresponds to this linear equation. There's only one line that goes through both of these 2 points. And we've now graphed the equation. Let's take a look at part D. In part D, we will repeat the same process, first finding the intercepts and then graphing the line. To find the x-intercept, we will set y equal to 0. Substituting y equals 0 into our original equation, we have 0 equals negative 2x plus 6. Subtracting 6 from both sides of the equation gives us negative 6 equal to negative 2x. Dividing both sides by negative 2, we have that positive 3 is equal to x. That tells us that we have an x-intercept of 3, 0, and we can plot that on our graph. We go to the right 3 units and stop. To find our y-intercept, we will set x equal to 0. Substituting x equals 0 into the original equation, we have y is equal to negative 2 times 0 plus 6. Negative 2 times 0 is 0, so we have y equal to positive 6. That means that our y-intercept is the point 0, 6. We can plot that point by going 0 in the x direction and positive 6 in the y direction. Now, by connecting these 2 points, we have graphed our equation. Let's continue on to example 3, where we will see some special cases. Let's take a look at what happens when we find the x and y intercepts for part A. With y set equal to 0, we have 0 equals 3x. This means that x must be 0. And our x-intercept is the point 0, 0. Following the process for finding the y-intercept, we would set x equal to 0, and that gives us y equal to 3 times 0, which gives us y equals 0. In other words, our y-intercept is the point 0, 0. See if you can picture what's happening here. If we have an x-intercept at the point 0, 0, that is the origin, then that is also a y-intercept. The point 0, 0 is on both the x-axis and the y-axis. The problem with this is we only have one point, so we can't sketch the line of this equation by using the intercepts. We need another point. The good news is we can choose whatever x value we'd like as long as it's not 0, since we've already done that one. Let's try x equals 2. When x equals 2, we have y equal to 3 times 2. 3 times 2 is 6, so y equals 6. This gives us another point on our line, the point 2, 6, where x is 2 and y is 6. Plotting this point on our graph, we'll go 2 to the right in the positive x direction and 6 up in the positive y direction. And now that we have 2 points, we can graph this equation. For two other special cases, let's talk about graphing horizontal lines and vertical lines. Here I've drawn a picture of the graph of a horizontal line that crosses the y-axis at a height of 3. Think about what the coordinates are for the points on this line. For example, what is this point? That point is 8 units to the right of the origin and 3 units up, so it's the point 8, 3. What about this point? It's 2 units to the left of center and 3 units up, so it's the point -2, 3. No matter what point we look at on this line, it's always going to have a y value of 3, no matter what the x value is. So the equation of this line is y equals 3. The x values can be anything, and no matter what they are, y is always 3. In general, if we have a horizontal line, its equation looks like this: y equals b for some real number b. It then necessarily has a y-intercept at 0, b, just like this one has a y-intercept of 0, 3. Let's take a look at example 4. In example 4, part B, we have the equation y equals -2. Since our equation takes on the form y equals some real number, we know that this is a horizontal line. We also know that it must pass through the y-intercept of 0, -2. We can sketch this pretty quickly. Starting with a y-intercept of 0, -2, we can draw our horizontal line. Now let's talk about vertical lines. Here's the graph of a vertical line, and it crosses the x-axis at the point -5, 0. Let's look at a couple points on this graph. This point up here is the point -5, 7. And this point down here is the point -5, -4. All points that are on this line are going to have an x value of -5, but all different y values. In other words, x can only take on a value of -5, while y can take on any value. The equation of this line is x equals -5. We don't even write the y because y can be anything, and no matter what y is, x will always be -5. It also has an intercept at the point -5, 0. In general, vertical lines always have equations of the form x equals a, where a is some real number. They also have x-intercepts at the point a, 0. Let's take a look at example 5. For example 5, let's look at a. Since this equation takes on the form x equal to some real number, we know that it's going to be a vertical line. We also know that it's going to go through an x-intercept of 4, 0. Knowing that is enough to sketch our graph. And there we have our vertical line of x equal to 4. We'll finish up this section by looking at some application problems. Example 6 reads that Nancy invests $10,000 in a new business and expects to make $2,000 of profit each month. Nancy's net profit, y, after x months have passed is given by the equation y equals 2,000 times x minus 10,000. Use the graph of this equation to answer the following questions. Well, first, let's graph it. I will let you verify the details, but we have an x-intercept of 5, 0. We also have a y-intercept of 0, -10,000. Let's sketch this graph. Notice that since we're working with such large numbers, I went ahead and counted by thousands on the y-axis. Also notice that since x is in months since she started the business, it doesn't make any sense to have negative x values, so our values will only go to the right of 0. The first question asks, what does the y-intercept represent in this case? That's the point 0, negative 10,000. This represents 0 months since she started. In other words, she has negative $10,000 in profit right when she starts the business. Part B here asks, what does the x-intercept represent in this case? That's the point 50. That means that 5 months after she started the business, she's made $0 in profit. Think about that for a little bit. If she started out at negative 10,000 and now 5 months in she's at 0, that means that's her break-even point. She has earned $10,000 in profit to pay back her debt to herself and take care of her initial investment. I will leave example 7 to you, and so this will conclude this lecture video.